She served as vice president of ASA from 2016 to 2018 and is a member of the National Academy's Committee on Applied and Theoretical Statistics from 2014 to 2020. She holds a BSc and an MS in mathematics from Arkansas State University and a PhD in statistics from Texas A&M University. She's a member of the Texas A&M College of Science Academy of Distinguished Former Students. We're very fortunate today. She's going to give us a presentation on the community analytics and the leadership role of statisticians. So take it away, Dr. Ensor. Thank you very much for joining us today. We're very much honored to have you give your talk.
Thank you, Marcy, and thank you, Elaine, for organizing and coordinating. And I really appreciate this opportunity to speak. And so this is one of my agenda items as president of ASA. And so I thought maybe it would be nice that I share this and open for any feedback and ideas that anyone might have. But the goal is to think about how statistics and the role that we can play in our communities. And for me in Houston, I call it urban analytics, but I think more broadly, community analytics and the role that we might play in that. Let's see here. So we all hear about the idea of smart cities and the important role of community analytics and that statistics can play. I'll discuss a little bit about Rice and Houston and our partnership, advocate for curated data and my role as the creator of the urban data platform for the greater Houston area. And then I'll actually give you some ideas of some case studies where I hope that I have actually made a difference. And that's in air quality, flooding, and then, of course, many of us have contributed to the pandemic, and so I'll talk a little bit about what I've done in that role as well. Several years ago, I helped organize a National Academy's workshop on frontiers of big data modeling and simulation for urban sustainability. And this was really eye-opening for me. And so, you know, we had company representation where private satellites have been put into space and are observing everyone around the globe. And so there's just a lot of data that's being created by our cities and by our communities. And then how can we capture that information to improve where we live, learn, work, and play. And so that's sort of the goal of this community and urban analytics. Following up the workshop were three webinars or a series of webinars. And I really, the reason that I'm pointing these out to you, that if you're interested in these areas, that I really feel that this set of material was really a great group that came together that can talk very broadly about what's going on in our cities. But Louis Betancourt and Constantine Costa focus on urban planning, and they both bring strong statistics and analytical tools to the urban planning environment. I picked on Sally Keller and Rihanna Price to explore sort of what are the emerging data issues and the data privacy issues that go with that. And then I teamed up with Scott Holland, another A&M grad, to discuss spatial temporal modeling for urban analytics. And then we brought it home with sort of the city perspective. Bill Fulton is the head of the Kinder Institute here at Rice, and Jean Holmes plays the role of basically a chief statistician for the city of Los Angeles. And so it was the idea of how can what we do help cities. And so this material is up there, and I really encourage people that are interested in this area to review that material. I don't know maybe not too many of you recognize this, but this is Rice University. And so we're clearly deeply embedded in the city of Houston. And I actually, what's in the background is the medical center. And so it just shows you how close Rice is to the medical center. But the point of this slide is that universities are part of our community. And so the goal is to use our research to action through cooperation and collaboration. Not just studying our cities as problems, but that we might want to solve, but actually working with our local governments to help incentivize change and immediate action where appropriate. So there's a couple of efforts like this going on around the nation. And so NORC at the University of Chicago certainly comes to mind, and Susan Paddock is their chief statistician. And so, you know, NORC really does work on city and local government infrastructure with data and decisions. The Urban Institute, of course, Rob Santos was the previous chair, a previous president of ASA, and he's now our head of the Census Bureau. So that's quite exciting. But the Urban Institute, you know, they partner with outside stakeholders to build evidence, share research, and identify solutions for practice. My good friend and former dean, Sally Keller, who was also the 2006 ASA president. She has a data science for the public good effort going on where their social and decision analytics teams partner with more rule-based governments to bring data science and statistical tools to action as well. And then again, at Rice, we have this reasonably, it's less than a decade old, but the Kinder Institute for Urban Research. And the goal here, again, you'll see the idea of bringing data to the decisions and engaging with the decision makers. Okay, and so that brings me to sort of my first role here, which is creating the Kinder Institute, the Kinder UDP, or the Urban Data Platform. And this has taken the last 6 years of a lot of my time, but I think it's highly, highly valuable. And the bigger goal of the Urban Data Platform is to think of Houston as your laboratory. So all of the information that we can gather about Houston is readily available for researchers around the world, and we are seeing that happen. So Houston is being studied widely and broadly because we are able to bring the data easily to the world. So what is the Kinder UDP, or the Urban Data Platform? So it is a virtual research development environment where we have secure data that's governed by HIPAA and FERPA laws. We also have an Amazon hosted library for published and shareable data, analysis software tools very broadly used. And the data that sits in our library, if we're able to share it, then it can be immediately downloaded for registered users. And then for the local users at Rice, we do have a SQL Server product that we maintain as well. But one key to the Urban Data Platform is that users themselves can publish data products. And so it's not just the data that we're able to gather and curate, but it's also the data that we're able to share. And I'll try to show some examples of that throughout my talk. But the idea is the data is vetted, it's cleaned and research ready. I mean, we can all scrape data, but once you scrape the data, then what happens to it? You know, you do your one-off project, and then it's sort of lost in the to the greater good. And so the goal of this is that the data about the greater Houston region, which is the 15-county region that surrounds Houston, is ready for researchers. In general, it's geo-referenced, so we can link across multiple data sets, and it's time-stamped as well. But it's published and archived with the idea of a one-stop shop. And the way that I designed the Urban Data Platform, we definitely built for sustainability. And so much of what we do, it's automated, and so it can easily run with 3 full-time staff. So moving from the idea of having a data resource to draw upon, I want to just talk about some of my projects in partnership with the City of Houston. And I like to think of this as quality data plus advanced methods plus partnerships, and really heavy on the partnerships. And so that informs our community solutions and our actions. And so it's not sort of a data to knowledge, but a data to action. And we want to, as statisticians, we want to bring the more sophisticated tools. So everything that we develop in machine learning and dependent data, spatial, space-time, all of these things can come into play. And, I probably am a little too broad in what I bring to the table, but I have focused more on sort of finding the right solution for the problem that's in front of me. And so I'm going to talk a little bit, and this, you're just going to get highlights of each piece. But the idea is engineering a statistical solution to some of the exciting opportunities that exist in Houston. So I'm going to cover 4 general areas. So there'll be the hyperlocal air quality, flood planning, and then I'll look at two projects within COVID. Okay, so the goal with the air quality effort that I'm partnering on in Houston is this real-time site analytics coupled with control charts. So we've got to be prepared for a new kind of administrative data as statisticians. And so this is an example. So this is a Google car that has an air monitor on top of it, and the car drives around the streets of Houston. Well, it turns out that Houston purchased these monitors for its whole city suite of cars. So just as the people in Houston that are serving Houston drive around Houston, then air quality measurements are taken. And so if you just think about that challenge, this is billions of points that come in, and they come in, in real time. And so we need to make some sense of this. And so what I've just targeted here, there's a metal recycling plant that the city monitors and is regularly in touch with. And so we just focused in on that and said, what can we say about this? And then any location that the city is interested in, we can easily stand up what's going to be this control chart. And then the control chart can drive actions. And so you'll see those pink dots, and that's the car driving around in these locations. And then there's the measurements that go along with this. And the point of this graph is, I don't want to get too much in the weeds, but the wind direction really matters in terms of the local air quality in that region. And so the wind direction is something that we want to take into account. And so what we built was this automated tool where the data literally comes straight from the cars, that are driving around into the analyst's desk, where it's automatically fed into what we call this site analytics Shiny app. So yes, this is a Shiny app. And there's a control chart that you can trigger that goes with this. But the goal of this is, I don't know if you can make it out, but if you look at this graph, every dot here is a measurement, and they're just continuously measuring. And what we're interested in is how the data varies throughout the day. And so, so just very simply, we have box plots that bin the data by hour of day. And these will be multiple days that go into this information. And then the modeling piece is this curve that you see that is capturing sort of the general behavior of what's going in the day. And then from that, we start looking at, you know, what is the standard deviation or the variation associated with our estimate? You know, what are the outliers? And then when we get into something like this, which is an extreme outlier, you would see on the controls chart page that we would signal there, and that would trigger an investigation by the city. And investigations are expensive. They have to go out with you know, more serious equipment to really try to understand what's going on. And so they don't want to do that if it's just sort of a small blip in time, but there has to be like a true issue that they need to investigate. And so this site analytics tool allows the analyst to sit there and target any place in the city and immediately bring up sort of this analytical tool for what's going on in that region. They can pick a particular day, they can pick a particular wind direction, whatever the analyst is interested in, they're able to use this to understand what's going on at that geo-referenced point without having to physically go there. And so there's 3 actions that come about from this automated system. So there will be alerts that trigger an investigation. The analyst has the tools to understand the dynamics, and then all of this information feeds back into the Urban Data Platform, and the information gets again curated and archived so that we can actually begin doing the studies of long-term health impact if there's a particular region that is of concern. And so another similar idea with the air quality, and again, this is real-time statistical decision-making, I guess. But the goal here is evidence-based recommendations during air events. And those of you not from Houston probably don't remember this, but there was the ITC fire in March through April of 2019. And so this was a major event. And during this event, the City of Houston Health Department found that they really did not have enough information to make informed decisions. And so this came about as, this research came about as a result of that. And it's funded by the CDC. And the partnership between the Houston Health Department, RICE, and the Environmental Defense Fund that bring in the toxicologists to the research. But the goal is to set up some criteria for informed action. So for example, one of the actions that was being considered, do we evacuate downtown Houston? And you know, you would think if the ship channel is a long way from downtown Houston, and so I would have never have thought of that level of question. But this is benzene that is going toward the city, and so that was the question that was being asked, and they weren't able to answer that question, and so there were shelter-in-place recommendations for the local residents, and then ultimately no action taken for the City of Houston. But the goal is to have a real-time display of measurements, and the city is adamant that they don't want any modeling at this stage. They want the information to be as close to the actual data measurements as possible. And the rationale there is that they don't want to have to try to explain models to the community. The modeling comes later. The dashboard will also inform the public. And then again, we're going to circle back, and that historical information is going to come back into the Urban Data Platform so that we can do our long-term health impact studies if needed. So this is an example of what we've built. And down here at the bottom, I'm happy to share these slides if anybody's interested, but this is the link to the app. And so this is actually a visualization where those ellipses are moving around with the direction of the wind. And I've just done a screen capture of one particular hour. And so what you see, there's a lot of data that's going in here. So the ellipses are the fixed site monitors for benzene in the region. But then you have this additional data, which is information that the city of Houston collected with their handheld devices or their mobile devices. And so, so the quality of the information is not all the same, and we need to take that into account. But you see these red measurements in downtown Houston, and so that's considered an extreme event, which could potentially trigger something like the evacuation of the city. So again, the goal is that all of that information is now at the fingertips of the decision makers, and they helped us in the development of how to communicate the information. And then the benzene measurements and the summary statistics, again, roll back into the urban data platform. And this is actually very important, because if you go back and you try to look at the historical data for the ITC fire, you'll find that a lot of it is not available any longer. And so this really rich information that is gathered in real time will be time-stamped and geo-referenced. It's cleaned. It's ready for statisticians to bring it into their research if that's this is an area that they're interested in. And it's published, so the data is actually given a digital object identifier, so you know that it'll be a permanent publication. Okay, so moving on to the next topic, and I just ask questions anytime. So my thought is I'm just going to go through each of these. So the next piece was Houston flood planning. And so there's two pieces here, the land use and land cover, and then understanding extreme rainfall. And you'll see just bits and pieces of where you know that your really high level statistical modeling and thinking can come in. So, you know, Houston, we really are learning to live with water. And not that I think we've known that pretty well, but definitely even Harvey was a wake-up call a bit. But the reality was, prior to Harvey, the floodplain maps for Houston were inaccurate, as much as 47% off the mark. And so the question is that 100-year return level is for rain, is that 13.5 inches, or is it something different? And so, you know, in this day of machine learning and data science, we tend to think of all data as being large, and I'm here to remind everyone that all data is not large, and all statistical problems don't deal with large data. And so this is how my explanation of this slide is. We were working with the hydrologists to come up with new floodplains for the greater Houston area. And so, so their flood modeling is done in these layers. And we were able to contribute to two of the later layers of their flood modeling, their physical models for flooding in Houston. So the two layers that we contributed to are land use and land cover, and then the rainfall distribution for watersheds. So first, let's just look quickly at the land use and land cover. And so this is, so I actually have a series of papers on this with my postdoc, Chris Hockenberg. He was an ecologist from North Carolina. He's now at Arizona. But this is big data. So this is billions of points. So this is looking at a 21-year temporal reconstruction of land use and land cover for the greater Houston area. It's a 30-meter resolution Landsat-based reconstruction. And so you can see the significant change from 1997 to 2017 in our satellite-based reconstruction. And why this is significant for the flood modeling is that the maps that were being used in the flood models were from 2006. And so so we have a 2006 map as well, but if you see this dramatic increase in 2017 so red is basically developed areas, then you see that tremendous growth of Houston that wasn't being accounted for in the flood modeling efforts locally. Okay, and so then let's go to the more statistically informed piece of work. And so this is changes in rainfall patterns. So we were asked to bring the best science to answer two key questions. And the questions were, have extreme precipitation trends in the Houston area shifted over the past century? And how are these changes related spatially? Our answers were to be communicated through return levels, which are basically the quantiles of the distribution that also incorporate the frequency of events. So on average, we should see something this happen every 100 years. We were also asked to focus on gauge measured rainfall. And you might say, well, who's asking you this? Well, so we're working in collaboration with the decision makers, with the hydrologists that are working with the decision makers to redesign the policies and laws within Houston. And so here's, so this is 24-hour rainfall by watershed within the Harris County Flood Control District. And so every line is a 24-hour rainfall measurement. I've not plotted any measurements from 0 to 1 inch just because the plot becomes too dense. The green lines here are the 100-year return level standards. And so then you might say, well, what are the red areas? So the red observations are every 24-hour rainfall event in the past 100 years that is above that design level, which is the purple line. And so that's why we say, Houston, we have a problem. And so if we focus on a single monitor, and this happens to be at Hobby Airport, then I'm gonna just put this in a time series setting where I have 24-hour rainfall from 1939 to 2017. And then note that, I guess, whoops, sorry. I'm not gonna, the screen is covering my, so the, really having trouble here. Okay. So anyway, Harvey was a multi-day event, and that was what was indicated on that slide. Okay, so if we again move to just this Hobby Airport, and I'm just sort of building up to how we're going to do the modeling. So you see three jagged lines here, and those are the actual observations. So it's a 40-year moving window, and so you actually see the rainfall of 40 years moving throughout, and then just simple trend lines that are through those. And again, that's the 25, 100, and 500 year quantiles, basically, or return levels. And so the question is, you know, are those trends real? Has it really increased? And if I can figure out how to change my slide here. It's not changing, or is changing. Yeah, there we go. All right, so there may be a few extreme value modelers in the crowd, but this is my catch slide that modeling extremes is extreme. And so, you know, we really are trying to bring forward kind of the best statistical science to this question. And the shape of the distribution that you choose is very important for extreme value modeling. And so I have written a few papers in extreme value modeling, but mostly, our papers always sort of add value in different directions. But my goal here would be to really stand on the shoulders of our giants and trying not to slip. So we do bring forward as a community a very rich set of knowledge about extreme value modeling. And then the question for me was, could I assimilate that knowledge to answer the questions that were asked of me? And so the basic modeling paradigm that we followed was that of Cooley, Nitschke, Naveau of a JASA 2007 paper. And we did this first for time and then for space. So it's our data model was a peak over threshold generalized Pareto distribution. And then our process model had a latent process driving the rainfall patterns, which was a non-parametric trend plus a Gaussian process. And then from the parameter perspective, we ended up using sort of the plug-in method where we plugged in the maximum likelihood estimates, and that seemed to be sufficient for our goals. So there's nice R packages that facilitated this. And so then our final goal was to get a model for the process and the parameters given the data. And we were able to do that. And so for the flood modeling, it's important that we give an answer for each region. And so this, you see the blue region, the red region, and the green region, because these are the hydrological regions, and they need one value to feed into that region. And so that's what we've done. So we brought forward a inference at the regional level, which is a point to area random extreme value estimation applied to extreme value parameter estimates from each location. So basically we fit the best extreme value model to the rainfall series at each location, took the parameter estimates from those models, and then used that in our spatial temporal modeling. The other unique, interesting piece is that you'll notice that the regions are all of irregular shape. And so we brought in the idea of the extended Hausdorff distance from the spatial perspective. And then from a research perspective, we can add priors for Bayesian inference, but that wasn't necessarily of interest to our collaborators at the time. And so if we look at the trends for each of these regions, we do see, and again, each plot, there's three curves. So it's the 25-year return level, the 100-year return level, and the 500-year return level. And so, for the central part of Houston, we do see a significant increase in the 25, 100, and 500, and the same for the northwest region. But then when you get down to the green region, which includes Galveston, the trend, the increase is not as dramatic, but remember that there have been significant floods in Galveston over the past century. And so this is also a good point for me to make here, is that this answer on this page was actually statistical research. So we developed new methodology to bring forward these solutions. And Carly Fagnant was my PhD student, and this was the subject of her dissertation, and a very successful one at that. Okay. All right, so if we go back to the statistical engineering in action, so we, from the flood takeaway, so what did we show? We showed that there was a dramatic increase in developed land over the last 20 years in the greater Houston area. We showed that there were significant positive trends in return levels for some gauges regionally, it's important that the rainfall is modeled accurately within watersheds, and we've been able to do that. And all of this information is input for those hydrologic flood models for the region. And so we were part of the conversation of the new rules for Houston. And, I wasn't in the room, but my knowledge was in the room because I shared it with the people that were in the room. And so I think that was very important and very influential. It was only influential because we were collaborating with the key decision makers and the influencers, and that we could answer the questions that were asked and answer them on time. And so, so those 2 points, we didn't answer what we wanted to answer. We answered what was asked, and we answered it on time. Were critical to be able to contribute to this. Okay. All right. So any questions before I move on? We got everyone doing okay? Okay, so now moving forward to SARS-CoV-2. So I know that many of us around the country and around the world are contributing to this conversation. But I think I had the opportunity to contribute in kind of a unique way in Houston. And it is because I've been engaged with the city of Houston in these partnerships. And so it was natural that they reached out to me. It wasn't necessarily natural that I would answer, but I did. And so I'm going to talk a little bit about 2 things. First is we really wanted to understand the actual prevalence of SARS-CoV-2 in the Houston community. And so we conducted a very extensive antibody study. And the partners here, again, were the health department, Rice, and then Baylor College of Medicine. So Baylor College of Medicine, Elaine Szymanski is a leading epidemiologist in the city, and Pedro Piedra is a leading virologist. So when I say leading, I mean they're international leaders, and we're just fortunate that they're in Houston. And then in the health department, we have Stephen Williams, David Purse, and Deborah Banerjee, and then also Lauren Hopkins. So Lauren is also a member of our department, but she has this dual appointment between the health department and statistics at Rice. And so that really does help facilitate these collaborations. And one of the reasons that I like to show this is because this really goes back to our core sampling ideas. And anybody, I don't know, I guess to see Bill on here, I was really a sampling enthusiast as a student. And so I got to use that knowledge. And so I did design a very rigorous sampling design for the city of Houston. And it actually ended up proving incredibly powerful in the information that we got. So one of the first things that we did is because we had a lot of PCR information about our residents. And so basically in Houston, the health department has extremely well curated data about the city of Houston and its residents. So we knew a lot about sort of what everybody else knew about, everything that you're seeing on dashboards and things like that. But we didn't really know exactly what was going on. And so, but based on that sort of preliminary information, we just divided the city into 2 groups that we call low prevalence and high prevalence. And this is just based on the positivity rate from the PCR test. And so the blue region is the high, the yellow region is the low. And then we're going to start sampling. And so we sampled in each group 30 census block groups. They were randomly selected. And then within each census block group, we sampled 7 households. And then within each household, all individuals within the home above the age of 5 were invited to participate. And so from that, we received blood sample information on 678 residents living in 428 households. And so, you know, a very well-designed study that gave us excellent information about the overall prevalence within the city of Houston. And we were also able to identify based on gender, race, ethnicity, and age groups. And so what we found, and this is basically in the September 2020 timeframe, you know, when the positivity rate in Houston, you know, was around 3 or 4, you know, so we thought that it was actually pretty low. But we found that the prevalence in the high strata region was actually 18%, and in the low strata region was 10%. And the confidence intervals are wide, but not quite that wide. But the prevalence was more than a factor of 4 of the PCR nasal clinical case counts. And so that was incredibly useful information to the health department. A similar study was conducted by Harris County 4 months later, and similar findings as well. And so this information directly informed health department actions. So we were able to identify neighborhoods that were most at risk, and the health department was able to send out strike teams. But I love this example because this is really classic statistics in action. And you know, it did take me a day or two to remind myself of all the rules around sample design. And so it wasn't necessarily easy. All right, and so now to finish up with sort of the major piece. So my second COVID effort is that I did join the RICE team to help set up a wastewater surveillance program for the city of Houston. And we are one of the largest programs in the nation. And wastewater is emerging as a viable public health management tool. And so again, the idea is to turning measurements into action. And I'm just going to give you a few of the statistics behind this. We did make the New York Times front page above the fold. so you know, it's your claim to fame, right? You make the New York Times. But Houston is an example of how incredibly powerful this is. And you'll see that my collaborator, Dr. Hopkins, is quoted here. And so here's our team. Originally, Baylor College of Medicine was also part of the team, but eventually their efforts were folded into the City of Houston regular operations. And so now the team is the health department and then Rice University, but a lot of us at Rice. And Lauren Stadler is an assistant professor at Rice who is a wastewater epidemiologist. And Lauren Hopkins' picture at the top, she really is the driver behind much of this because she's able to secure the funding, and together we can come up with the vision for what we might be able to accomplish. So this is a significant investment. I mean, at the order of $5 million to set up sort of the sampling and the lab pieces. And so, you know, this is real engineering. And so it's basically, you know, we collect data from all over the city, it goes to the lab, then it gets genetically analyzed for whether SARS-CoV-2 is there. Then I get that information and I summarize it into some answers, and then, or some insight. And that insight goes to the health department. And again, it drives decisions in terms of what the health department does. So we're able to come up with estimates at the zip code level so they can identify which neighborhoods are most impacted, you know, week to week. And so my arrow is that arrow, but it's one of the most important pieces. So this is just an example of the type of sampling that goes on. So every one of these colored regions represents a wastewater treatment plant. And so there'll be a measurement from each of those but as well as measurements from schools, nursing homes, shelters, lift stations, jails, etc. So there's a lot of data that goes into this, and we received the data on Friday. Our reports are ready by Friday afternoon, and the public dashboard is updated on Monday. So here's a little bit of the messy data. So just to so I've just pulled out one wastewater treatment plant to show you how messy the data might be. And then we roll that up into an estimate for the whole city. We are able to predict from this. And this is an example of the results that we might communicate, where the top curve is this really extensive estimate of the wastewater viral load within the city. And then the bottom curve is actually the PCR positivity rate for the entire city. So you can see that they track pretty well, but the positivity rate, we don't get that information immediately. So that's always a couple of weeks behind. And we do get the wastewater information immediately. And so here's a shout out for heat map for communication. So we really had to work with our health department officials to ask, how did they want to receive the information? And so this is a temporal heat map where each wastewater treatment plant is given each row. The total for the whole city is the top row. And so you can see the Omicron surge, the Delta surge, and then this is the July 20 surge. So we're sort of doing pretty good right now. We do have an email that goes out that just summarizes everything, and we try to keep a similar format to that. And then we're also tracking all the variants within the city. And again, we have landed on this sort of heat map approach to communicating a lot of information in one slide. And so I've just included Delta and Omicron here for your reference. This is Delta and Omicron on the right, and you can see that most of the Omicron has left the city, although some of the smaller regions, it's still being detected. So the goal here is that the city does act on our information, and I think I probably have gone over that. So wastewater epidemiology, it's scientifically sound and robust. We were able to develop a semi-automated system so that we can turn around actionable information in real time. The whole nation is going to be doing this. CDC is really putting a lot of effort behind this. And so I would say that this will become a common part of what health departments have in their toolkit. So if we go back over these projects, so I'm summing up. So the UDP, the Urban Data Platform, really a big shout out for this idea of curated, research-ready, published data that receives a DOI. On the air quality side, we have real-time information for knowledge, but then followed up with that curated data for the longer-term public health studies. From the flooding perspective, we were able to highlight the urban growth, and then we quantified the spatial temporal change in rainfall. And most importantly, we were able to scientifically inform the conversation on policy for the redesigned Houston. And then for COVID, the seroprevalence study, it really did help the city understand the extent and the impact on our community. And then the real-time surveillance through wastewater epidemiology is here to stay. And what we're doing now is making sure that we get all of the technology behind that working in a relatively seamless way for the city. So summarizing, community analytics, why, when, and how. So why can we have an impact? Well, we have to be ready to engage. We have to be willing to engage. We have to come up with answers now, and that may delay our core research. With my flooding example, I did want to show that it didn't do away with the core research, it just might delay it. We are building on strength of long-term collaborations, and we have to respect the collaboration. So that means that I'm not going to run out and, you know, tell the newspapers what I'm doing before I tell the city what I'm doing. So you do have to respect the fact that you're working on public information and kind of control the flow of that information. The infrastructure, like the Kinder UDP, there was enough of that effort already in place and in the right direction. We also had very strong university support, both financially and for recognition of the importance. And then I would just say the strength of statistics and data science research and resources. You know, what we do really, really does matter, and it can have a real impact in real time. So why do I choose to engage? Well, it is the chance to have a real impact. You know, I want to engage in projects where the impact is high, and that I bring a unique and important knowledge or perspective. I have grown to where I only want to work with functional teams. And so if I enter a collaboration and the team doesn't seem functional, then I'll, you know, just sort of quietly slip out of the way. And there needs, you know, ideally there would be interesting statistical problems down the road, and then how funding / time, it has to be available, or there has to be a path for this. So from the ASA perspective, so leaders in our community are tackling these kinds of challenges. And my goal is to think about, you know, is there something that we can do collectively, more of a collective voice from ASA? And then how can ASA serve our membership and communities by facilitating leading statistical efforts towards smart cities and community analytics? So those are the kinds of things that I'm thinking about and working on as president. And I would really welcome any input on that. And with that, I will stop and thank you, and take any questions that anyone might have.
Hi, Kathy. This is Mike Longnecker.
Oh, hey, Mike.
Great talk. I was wondering on the COVID material, you know, as political as it's become in Texas, did you get any feedback from some of our noted politicians in the state?
You know, I don't think I did, but, you know, I'm pretty well insulated within communicating to the city. I do think that our local health department worked hard on coordinating with the state. So I think they tried hard not to have too many confrontations, but, you know, they did make decisions based on this information, and maybe the decisions weren't in line with state decisions, but, you know, that's a little separate from me, I guess.
Just to let you know, I worked on several years. We've been working on a project in Houston at the effectiveness of spraying for mosquitoes, which are a vector for multiple diseases. And so we've also worked with the health department down there. There are lots of opportunities for statisticians to get involved if you want. People.
That's right. Did you find it? Have you found it worthwhile?
Oh, absolutely. Yeah, it was a lot of fun. Great data. I was working with faculty on campus too. So they were really the interface between the health department and us.
Yeah.
So it was really interesting. It's a lot of fun. And we've got 4 or 5 papers out of it too.
Yeah.
So that's always good. Being an academic.
So now we need to get your data back onto the Urban Data platform.
Exactly.
complete my circle. So,
there we go.
yeah, that's great to know that you're doing that. Yeah.
Well, I'm retired now, but that was last year.
So did you have you completely retired, or have you?
Well, no, Ronnie, I retired on August 31st, and then Ronnie had me come back. And actually, I got 3 more papers we're working on now with people in there. So hopefully I'll retire pretty soon. At least is getting impatient. that we need to get on the road traveling.
Well, you can take your computer with you.
Of course. Always have.
Yeah, that's right. That's right. Hi, Elaine.
Hi, Kathy. Very interesting talks, very exciting. Don't really have too many questions. I will say that we've taken over data coordination for the rare disease research area, and the whole idea of curating data and making it available to rare disease researchers broadly outside of the network is a huge goal for us and a huge challenge for us as well, because we're talking about research studies, and none of them have used standardized methods for collecting the data, et cetera. But I thought your examples in your talk were extremely interesting and great work.
Thank you. Thank you. Yeah. This curating the data is much harder than we like to think about, right? So
It can be a little bit overwhelming, actually.
yeah, I feel like I've done my part now. So, creating the urban data platform, now I get to use curated data going forward.
There you go. And figuring out what the right platform is and what the right tools are to make available too, quite challenging. So we're just kind of starting the process.
Yeah. So great to see everybody.
There's a question in the chat. Let me see.
Okay, let's see.
Well, I think Melinda Holt just said, thank you very much. This was fascinating.
Thanks, Melinda.
We have a couple more minutes if anyone has a question for Dr. Ensor before we wrap up today's presentation.
Was the story too overwhelming, or did I tie it together well enough?
No, I think it was well done. I think it was very interesting how you gave some really excellent examples of how we may impact the community with our training and expertise.
Yeah. Well, and there are things that, sort of your bachelor's level data scientists can't do, right? So,
right.
So it's something where that advanced training is really needed. So.
I especially liked your example with the COVID wastewater, because I was talking to a microbiologist in Wyoming several months ago, and they were talking about, actually, in their case, it was feces, and so I thought, wow.
Wyoming's also doing wastewater. Yeah.
Yeah. It was great to see your example of how it's being done down here as well. I thought, oh, that's.
Yeah, well, it's a huge investment by the city of Houston, but you can take it further. I mean, they can look for like we're testing for flu and just other things. You can also test for opioids, for example, or HIV, and so you can just and they do stuff with the information. It's not just finding out that it's there, but they'll send what they call strike teams, which is basically a huge support system to a community to try to encourage vaccines or just see what's going on, to see how they can help in that area. And so I think it really does make a difference. Well, at least I hope so, because it's been a lot of work. Yeah. When you help to invent a new drug, that it makes a difference, right? So yeah.
Yeah, I like the fact that you shared some examples that some of us might not have thought about, right? Like you said, when people are working on a new drug, it's a little bit more obvious, but there's a lot of these things that you're working on that are behind the scenes that really do impact the community, every single one of us. So right. It's very interesting.
Yeah. Yeah, it's nice to be a full professor so you can do whatever you want.
A lot of hard work getting there, right?
Yeah, that's right. So
now you can have fun. Have fun with your projects.
Yeah.
Continue making a difference.
Mm-hmm. Well, and I do hope to sort of pull together, because there's a lot of us tackling these kinds of problems, like Mike just shared his story. But I don't think collectively as a community, we talk about that enough. And so maybe ASA can help facilitate sort of that collective vision around sort of engaging, you know, this university local government partnership idea. So
Yeah, it's a great idea to share this information with everybody.
get a thumbs up from Bill.
Yeah, that's awesome. Well, we are past the noon hour just by a slight bit. So I want to thank you for sharing all of this insight and expertise with us and helping us understand how we can impact the community, and perhaps this will be some encouragement for others to do that. And it's, you know, it's very nice to have one of our own Aggies share this with us. So thanks again. Thank you very much.
Thank you, Marcy. And thank you everybody for attending.
If I can add, we are proud of you, that you're our Aggie.
Thank you, Ronnie. I really don't think I would be where I am if I hadn't chosen A&M. So I am so fortunate that I made that decision in life. All right.
Gig 'em. Have a good day.
Everybody have a great day. And thank you again
Thank
for
you.
attending. Bye-bye.